Welcome back to Hypothesis Testing Done Right, Part 7 of 14. In Part 6, we computed Sam's power and saw his T of 1.69 barely clear the one-sided bar of 1.65. But that bar depends on a choice we have not yet examined, which tail the rejection region sits in. The shape of the alternative decides it, and you must commit before you look at the data. The shape of the alternative decides where the rejection region sits, and you must commit to it before looking at the data. Sam had a directional prior. The reversal rule was supposed to make money, so the alternative mu greater than 0 is a one-sided or one-tailed test, with the entire 5% rejection region in the upper tail, critical value about 1.65. Contrast Maya, who is comparing loan approval rates between two neighborhoods and testing whether they differ. She has no prior about which is higher. Either direction would be a finding. Her no is that the difference between the two means is 0, and her alternative is that the difference is not 0, a two-sided or two-tailed test. Now the 5% must be split across both tails, 2.5% in each, so the critical value moves out to about plus or minus 1.96, the famous 1.96 of large sample testing. A two-sided test is more conservative. You need a larger statistic in absolute value to reject because you reserve part of your error budget for surprises in the other direction. This creates an obvious temptation and an absolute rule. The temptation, run a two-sided test, see that the effect is positive, then retroactively claim you always meant the one-sided test to get the easier 1.65 cutoff. That is cheating. It secretly doubles your true type-by rate from 5% to effectively 10% because you gave yourself 2 bites at the apple. You would have rejected for a large positive result, and you would also have been ready to reject for a large negative one. So the rule is absolute. Choose the sidedness from the science before you see the data. When in genuine doubt, use two-sided. It is the honest default, and most published finance results are reported two-sided for exactly this reason. Sam can justify one-sided only because the reversal hypothesis was directional from the very start, and even then, reporting both is the cautious move. The discipline here is the same one that runs through this whole chapter. The decisions that protect you against fooling yourself must be made before the data can tempt you. To summarize Part 7, the shape of the alternative hypothesis decides which tail holds the rejection region. A one-sided test puts the whole 5% in a single tail, with a cutoff around 1.65. A two-sided test splits it, 2.5% in each tail, pushing the cutoff out to about 1.96 and making the test more conservative. The unbreakable rule is to choose sidedness from the science before you see the data, because switching to one-sided after peeking secretly doubles your true error rate. When in genuine doubt, go two-sided. It is the honest default. In Part 8, we turn from yes or no verdicts to a continuous measure of surprise, and we nail down the single most misremembered definition in statistics, the p-value.